Welcome to my video. We are now in laboratory exercise number 5, the second method using MATLAB. So this activity will allow students to implement secant method using MATLAB, Mathematica, or similar software. The objectives are, at the end of this activity, the students are expected to have been able to construct a function script using MATLAB, demonstrate your understanding in secant method, understand and implement secant method to find the root of a function using a software. And the materials needed that we need to use is MATLAB, Mathematica, or similar software. So here's the procedure number 1. The pseudocode can be found in Numerical Mathematics and Computing, 6th edition, Ward, Shanae, David Kincaid, page 112 to 113. For procedure number 2, we need to demonstrate secant method using MATLAB and calculate the roots of a user-defined function with the following specification, like this below. And number 3, we need to put all these codes on *.m script or suite of scripts that is loadable in MATLAB. The MATLAB function should accept the user-defined function as an input argument and produce a variable containing the answer. Example y. Alright, this is now our MATLAB video using our pseudocode of the secant method. We use the secant method if we find it hard to get the derivative of the given function. The secant method is a root-finding algorithm of uses a succession of roots of a secant lines. The better approximate a root of a function f, it can be thought of as a finite difference approximate of Newton's method. For question number 1, what is the equivalent line of command in your script? The answer is we need to enter our function to the power minus 1 and then put an initial 1 and an initial 2. So here we could see our number of iterations and the number of the root is 1. For question number 2, suppose you enter the same arguments to Newton's method and secant method. Is there a significant error between the two of them? The answer is no. There's no significant error appear between Newton's method and secant method when we enter the same arguments. For question number 3, what is the advantage of secant over the Newton's method in computer implementation? The answer is the advantage of secant method over the Newton's method in computer implementation. It converges at faster than a linear rate and it doesn't require to use of derivative of the function. It also requires only one function evaluation per iteration as compared with Newton's method, which requires 2. Question number 4. What can you conclude from this activity? I therefore conclude that based on our results and discussion using MATLAB, we now conclude that the secant method is formally the most effective of the methods we have considered here in study. This is equal to the fact that it has a converging rate close to that of Newton's method but requires only a single function evaluation per iteration.